Hello, let's solve few questions here. In the last video, I told you about what a polynomial is. It was the first thing. If you have not seen it, please refer to it. Now, the question is, which of the following expressions are polynomial? So once again, let me just revise what we mean by polynomial. Polynomial is an expression where the variables are having non-zero एंड नॉन नेगेटिव पावर्स. फ्रैक्शन नहीं होना चाहिए पावर का, और पावर पर कोई नेगेटिव पावर नहीं होनी चाहिए. अब पहला वाला देखते हैं. एक्स टू द पावर ऑफ 4 माइनस 2x क्यूब प्लस 3x स्क्वेयर. हियर द वेरिएबल इज x. Very clearly you can see x is the variable and the power throughout is all positive 2, 3 and 4. So yes, it is a polynomial, right? This is a polynomial. So in order to conclude that it is a polynomial, variable should not have negative power or fractional power. Just remember these 2 points. Now what about this one? This is just a single constant. So sometimes you might have a confusion whether this is a polynomial or not. Yes, this is a polynomial because we can express it as plus 1 and with a variable having a power 0, right? Here again 0 is neither negative nor positive, so it is allowed. Okay, so this is also a polynomial. In this case, this is x, this is 1 by x. X minus 1 by x is not a polynomial. Why? Because this becomes x minus 1 by x. I can write as x to the power of minus 1. And here I am having negative power, right? Because it is having negative power, so it is not a polynomial. So in order to this be a polynomial, as we know that polynomial variables cannot have fractional or negative power. So this is not a polynomial. Fine. Now let us see the next one. It is y square minus 2y plus root 3. This is a constant term and variables are y square and y. None of them are having any negative or fractional power. So this is very much a polynomial. What about this? Root 3 y cube. The variable is having power 3 and in this term variable is having power 2 and here variable is having power 1. So there is no negative power or no fraction power. So this is also a polynomial. What about this? Not a polynomial. No, this is not a polynomial because this term, the variable is having power of minus 1. That's negative power. Now in this case, this is y square minus under root of y. What about this under root of y? Because this can be written as y square minus y raised to the power of half. Under root, we can write it as 1 by 2. So here we are having a fractional power. So this is not a polynomial. Hope this point is very clear. Again, in this case, you have y cube root of y, right? Cube root of y means y will be written as y raised to the power of 1 by 3. Again the fractional power, right? So this is also not a polynomial. Now in this case, x is having power 107, which is a positive and it is not negative. So this is very much polynomial. And this is again not a polynomial because it is y raised to the power of 1 by 5 fractional power. So this is not a polynomial. So hope by this question you are very clear to identify what a polynomial is. Just remember, once again I am revising that in polynomial the variable should not have negative or fractional power. Okay. Now let us move to the next question. Write the degree of each of the following polynomials. Fine. Now here you just remember degree is nothing but highest power. Highest power of variable, no matter whatever is the variable in the expression. But highest power you have to see. Now first one, x to the power of 4 plus 3 x square plus 2x plus 5. Here the variables are x, and the highest power x to the power of 4. So 4 is the degree. Degree is the highest power. You will just write its degree is 4. In this case, the variable is x and its power, highest power is 1. So degree is, in this case, degree is 1. In this case, x square. So degree is here 2. It's very simple. Hope you can understand it very clear. Can you tell me the degree of this? If anybody, please write it in chat. If you can say, here x is the variable, irrespective of root 2. Don't bother about root 2, x cube. The highest power is 3. So degree is 3 in this case. Fine. What about this? Yeah, this is interesting. Here there is no variable. I can't see any variable here, but it is there. I can write this as plus 9, say x to the power of 0. So there is a variable, of course, and having a power of 0, because anything to the power of 0 is 1. So I can as well express this 9 as plus 9x to the power of 0. So in this case, the degree is 0. Fine. What about this? This is slightly complicated function. So first of all, you just expand it. Or if you can do it orally, you can also do it the other way, because x minus 1 is raised to the power of 2. So if we expand this, I'll get a term, highest term, x square, which when will be multiplied with x square will give you x to the power of 4. So its degree is going to be 4. Let me show you how. See, let's keep x square as it is and expand this using the identity a square, a minus b whole square, that is a square minus twice ab plus b square. And then in the next step, you can just carry out the multiplication if you want, or otherwise it is clear by now. This is x to the power of 4 minus twice of x cube plus x square. The highest degree is, highest power is 4, so degree in this case is 4. Fine. What about in this case? Now here you may get confused that x square is in denominator, and as I told you in my previous video that if the variable is in denominator, it is x raised to the power of negative 2. Okay, but in this case it will not go like that, because if we simplify this, what we get? We get x cube divided by x square, because I am just taking this inside the bracket. This is x to the power of 4 divided by x square plus x to the power of 8 and the square. Here this cube will cancel. This will cancel. You will get 2 here, and here this is x square, and you will get 6 here, right? So what is the degree in this case? In this case, the degree is going to be 6, because the highest power of x is 6 in this case. Fine. So hope by this question, the idea about the degree of a polynomial is clear. Degree of a polynomial is nothing but just the highest power of the variable in its simplest form. Even if the expression is given in a complicated form or in a composite form, you've got to simplify it to keep it in standard form. Fine. And then check which variable is having the highest power, and whatever is that highest power is the degree of that. Okay. Now another question quickly we will see, then we will move to the new concept. Now write the coefficient of x square in each of the following. What we meant by the coefficient? Coefficient is the numerical part associated with the variable. Okay, that is, if this is x square, if this is x square, And what is the number associated with it? Is 3. So 3 is the coefficient of x square. In this particular case, 3 is the coefficient of x square. If I ask you what is the coefficient of x, then you will just find for x. So this is the term which is carrying x. And the number associated with it, the constant associated with it is 4. So that is 4. 4 is the coefficient of x. Let's see in this. What's the coefficient of x square? The coefficient of x square in this case is, this is the term having x square, and the constant part is 6. So 6 is the coefficient of x in this case. What about this? Here we have, this is the term which is having x square, and minus 3 is the constant part. Okay, so minus 3 is the coefficient of x square in this case. Now what about this? You can try this yourself, and I give you the answer. This is the term which is having x square, and minus 6 is the constant associated with x square. So minus 6 is the coefficient in this case. Okay, so hope these things are clear. The idea of coefficient of a term, idea of degree of a polynomial, and also identifying what a polynomial is. Okay, let's in the next session continue this. If you haven't yet subscribed the channel, please do subscribe the channel and also share it with your friends. We will continue the next part of it, that is linear relationship or patterns. What is it? What does that mean? Let's see. Now just look at these things. This is 1 square, say stage 1, and here we are having stage 2 and 3 squares. Never mind my drawing, right? And here we have this is stage 3, stage 2, stage 3, and let me take another one. 1, 2, 3, and let's call it stage 4. Fine. Now see, if I compare the number of squares and the stage. First stage, I have 1 square. This is stage, and this is number of squares. In first stage, we have 1 square. In second stage, we have 3 squares. In third stage, we have 1, 2, 3, 4, 5. So totally 5 squares. And in fourth stage, we have 1, 2, 3, 4, 5, 6, and 7 squares. So here you have to think of a relation between the number of stage and the number of squares. Fine. Now very clearly we can see that the number of squares and the number of stage. Say for example, if I take second stage and I have number of squares is 3. So 2 times the number of stage minus 1 is 3. This is the number of squares I have, squares. And this is stage, right? Let me try this for the third one. 2 times the third stage minus 1. 6 minus 1 is 5, which is right. Another one I can try. 2 times fourth stage minus 1 is 7. Yes, that's also true. So we can generalize this. This is how, this is just purely observation. By observing, we have to develop a relationship between the stage and number of squares. Quite challenging at the beginning, but once you practice a bit, you will be able to do it comfortably. Fine. So if I generalize this, that is, this 2 is throughout constant. This is only varying. Okay, so I can write down number of squares is twice of the number of stage minus 1. Okay, so to this number of squares also I can give a variable like n. Capital N is equal to 2 small n minus 1. Okay, now this is our relationship. What is the variable here? Variable is this n, because this keeps on changing, like second stage, third stage, fourth stage, fifth stage, and so on. Now, once I have this relationship, how does this relationship helps me? If you are asked what will be the number of squares in, say, ninth stage, once you are very clear and convinced with this relationship, you will be able to say number of squares will be 2 times the ninth stage minus 1, that is 17 squares. Hope it is clear. Okay, so in next session we will do questions related to this. Till then, stay happy and also try to understand. In case you liked my video, do subscribe the channel and also share it with your friends. Thank you very much. Bye bye for now.